Hi guys, this tutorial video will take you through the deductive proof of the Pythagorean trig identity, which is sine squared theta plus cosine squared theta is equal to 1. So notice that I start off with a diagram of a right triangle, and notice I have the angle theta, the sides x, y, and r as well. The reason why I have all these parts labeled is because we're going to use this angle as well as each part of this triangle in order to prove that this is true. So I'm starting with the triangle. Now, what statements can I write down about the triangle itself? So we're going to ignore what we're trying to prove. We're not going to use this at all. We're just going to focus on this triangle. Well, if I take the cosine of this angle theta, what is that equal to in the context of this triangle? Well, cosine is adjacent over hypotenuse, which in this case is x over r. Okay, so I have a cosine here, and notice I'm going to need a cosine in my final equation, but I'm also going to need a sine, so it'd probably be a good idea for us to write down something about sine. So the sine of theta is equal to what? Well, it's equal to opposite over hypotenuse, or y over r. So what else do I need? Well, notice that this Pythagorean identity looks a lot like the Pythagorean equation, right? In other words, a squared plus b squared equals c squared. So I can write that down as well, but in my particular triangle, I'm not using a's, b's, and c's. I'm using x, y, and r. So what would that look like? Well, it would look like x squared plus y squared is equal to r squared. Okay, so I have my three given states written down, but notice that I'm going to need to replace these x's and y's with sines and cosines. The only issue is I don't know what x and y are equal to in terms of sine and cosine. I have some general statement written about cosine theta x and, oh, this should be an r. And I have some general statement written about sine theta y and r, but I don't know what x and y are actually equal to. So what I'm going to do now is I'm going to take these two equations and I'm going to solve for x and for y. In other words, I'm going to isolate x and y on one side of the equation. So how would I do that? Well, I would simply multiply both sides by r. And I'll kind of do that in both equations simultaneously. So the r's would cancel out, and I'd be left with x is equal to r times cosine theta, and y is equal to r times sine of theta. Okay, well now I'm almost done, okay? Because now I know what x and y are, therefore I can substitute x and y into the general Pythagorean equation. So we know that x is equal to r cosine theta, and so this is an x up here, so we can replace this x with our cosine theta, and I have to use parentheses because I'm squaring the whole thing, and we can replace this y with r sine theta. And that's equal to r squared. So let me tilt this way. Okay, so we're almost done. What we need to do now is we need to clean this up a little, because remember, we want it to look like this, okay? That's what we're after. So we need to make this look like this, and the way we can first do that is by getting rid of these parentheses. So r cosine theta, if we square both parts, we get r squared cosine squared theta. And remember, this cosine squared theta, what it really means in mathematics is that you're taking cosine theta and you're squaring the whole thing. Plus, we would do the same thing with the sine and the r squared over here. Okay, so we're almost done. R squared cosine squared theta plus r squared sine squared theta is equal to r squared. Now what I can do, in order to make it look like this, I can eliminate all the r squareds. And how do I do that? Well, I divide them out. So divide everything on both sides by r squared. These two go away, these go away, and these two get simplified to 1. So what does that leave us? Well, it leaves us with cosine squared theta plus sine squared theta is equal to 1. And there you have it. Okay? Long process, but everything is very mathematically precise. We're just using the substitution property in order to come up with one long equation involving r cosine theta, r sine theta, and r squared. And then what we're doing is we're taking it an algebraic step further to simplify it down to this nice and neat trig identity. Thanks.